Hey everybody, this is Larry. This is March, March 24th of the Leetcode challenge. It's not the today's challenge is not up yet, so I am going to do a premium question just because I haven't done enough of them and I'm trying to get my money's worth. Let's do a medium one because I don't know, take a nap afterwards or something. Anyway, today's Larry bonus question is 2495. Number of subarrays having even product. Hit the like button, hit the subscribe button, join me on Discord. Maybe I already said it. Okay, let's see, right? Okay, return the number of subarrays of nums having a even product. I think this is kind of a very hard problem. I mean, it's medium nowadays only because, well, just that people have seen it before, or maybe not this, but variation, right? Like there is a couple of layers to this, maybe two layers, if you will. But after that, it becomes a problem that people have seen many times, and that's why. Which is, but if you haven't seen it before, it could be very tricky. So definitely, let's do it together, right? The first observation is what makes a subarray having a even number of products or sorry, having a given product, right? And you kind of think about this, right? So there was only three scenario, and then it becomes is it distributive, right? Of things, right? Which means you have a even times even, and that becomes even, right? Makes sense. Odd times even becomes a even, right? And odd times odd is equal to odd. Is that right? Yeah, right. Because two times three is two, etc. Right? Oh, sorry, two times three is six, etc. Yeah. So I think that's basically the roadmap of what we are looking at with respect to what it means to be a product. And then now, what does that mean, right? Let's see. Let me think about this for a second. I mean, I could play. I mean, from this you can play around with, because now let's say you have, and like I said, the order doesn't really matter in this case because product is commutative, so or at least regular product. So then you could just move them around really. So then that boils down to number of odd numbers and number of even numbers within the subarray, right? Just to be clear, because this problem asks for subarray, so you have to do it with respect to the subarray, right? So let's say you have 5 O's, then it already just reduced down to 1 O, and then now if we have at least one Y in the subarray, then we're good. I think that was my initial gut feeling, my intuition, but I just wanted to kind of illustrate it out just in case I'm wrong because, well, we're doing here, it's not under as much time pressure as you would otherwise, but now I think I proved it a little bit, but I don't know if it's a good proof for y'all at home, but it's, but that's something to me. And also I wanted to kind of point out, here, that I think in many of my videos, especially the ones that are during the contest where my explanations sometimes or like you see me do it very quickly and I think for and very often I get questions about, well, how do I do these proofs so quickly, right? And the short answer is, to be honest, it's practice. And what do I mean by practice? It means doing problems like this one, right? Meaning that next time I see something like this where, I mean, maybe not next time because I'm a slow learner. So maybe like a couple of times, if I see this and I see another similar problem and I do it again about like, a bunch of numbers, if we're given a bunch of numbers and we want to find a product and whether they odd and even, well, now I have a little bit of a better sense of kind of like, maybe if I have done a similar problem like 4 times, the 5th time I'll just jump right into it and then not have to think about it, right? So that's usually, or that's very often what I mean by practice when it comes to kind of making these things speedy. It's because, yeah, I mean, I'm confident, I'm reasonably smart maybe, or at least I'm confident that I am. You may disagree at home in that, I'm confident that I'm able to figure this out for sure, right? We kind of figured this out. It's not too, at least for this problem step, it's not too bad. We figured it out. We talked about it. We maybe even proved it, right? But that takes time, right? How long? Yeah, I mean, we're like 4 minutes into the video, but so it takes minutes, and when you talk about a contest and you're trying to work on the speed, that's what practice buys you, right? Just want to kind of, it was a little bit of a spiel, but but just want to kind of talk to people at home so that this is what I mean by practice when people ask me about proofs and how to kind of prove it very quickly, especially during a contest or something when time is the most important thing, right? Okay, so now basically we're trying to get the number of subarrays where there's at least one even number, right? And there are a couple of ways you can maybe do this. Given I don't know that like you can probably do some like thing looking forward and backwards and then kind of like get the balance by even. But the way that I like to do it is or like the way that I've been kind of practicing, or not even practicing lately, but I've seen it a couple of times, so now I'm more aware of it because I think I'm still a little bit slow when it comes to it in the past, but now I'm getting this technique down a little bit better. And yeah, we'll talk about it, don't worry. But and what I mean by that is that instead of looking for the symmetry and then exploiting that symmetry, I'm actually going to I wouldn't say break the symmetry, but just kind of look at it in an asymmetric way. And what I mean by that is just, so given this array, instead of trying to figure out, I mean, there are a couple of techniques that can apply. But for example, like one way, it depends on how you ask it's a combinatorics question. So it depends on how you want to ask the questions, right? Like how many subarrays that have an even product include 6, and then maybe you do some maths on the left, some maths on the right, and then combine them in a way. And sometimes there's, depending on the problem, there may not be double counting or whatever, so you don't have to worry about it, and it maybe is easy, right? But for me, the other way to do it, the way that I'm more comfortable now, is by looking at this particular number and then go, okay, looking to the left, how many subarrays fit this property of whatever the question is asking, ending in this current arrow or current indexes or current position or something like this, right? Basically like the current thing that we're looking at. So okay, so I think that becomes a little bit easier because now we're saying, okay, how many subarrays fit this property ending in this current arrow? So we're going from left to right, and we're just summing up the number of subarrays that fit this property, ending in this current cell or array element or whatever. And here it becomes, these questions, especially for subarray, just becomes how many degree of freedom do you have, right? And the degree of freedom is just another way of saying how many choices can you make here to create a subarray, kind of. Maybe I'm using that wrong a little bit. I know that degree freedom also has a precise meaning in certain contexts, so if I'm messing it up, please forgive me. But yeah, and basically the idea here is that, as we said, now we're just looking for the number of subarrays that contains at least one even number. And so now, another way to, let me start the arrow from the 9. Here, going left, there's no even number, so it's 0, right? Looking at 6, 6 is an even number, so everything going to the left of it is going to be good as long as we have, and how many degree of freedom do we have, right? Well, it has to contain the number 6 because, we're literally counting the number of subarrays that ends with 6. And then we could take the 9 or not. So that means that there's 2 choices, right? Because there's 9, 6 or 6. So this is 2, right? And then look at 7. 7 is the same thing because now, how many subarrays that fits in 7? Well, what is our degree of freedom? How many choices can we make? Well, we have to take the 6 because otherwise there's no even number. So then now we have 9 or no 9. So the degree of freedom is 2, right? For more illustration, let me change the example up a little bit. So ignoring how everything adds up, but let's say we have another number, another few odd number for now, and then now we go, okay, let's say we're looking at 7 again still. We start at 6, and then now we have 4 degree of freedom, right? Meaning that the subarray can go 7, 6, it can go 7, 6, 9, 7693, 76931, right? And just to be clear, in this case, of course, if you kind of thought through your logic, if you have another even number, it doesn't matter. It doesn't affect the 7, but it might affect, say, the 9, right? Like the 9 now, it only goes, or it only has to go to the 2, but the 7 just goes to the 6. So now, as we play around with, excuse me, as we play around with how we word the problem and rewording what the problem is asking for, then now we can say, what is the closest even number, and then like play around with the indexes, and then that'll be giving you the number freedom, and then you sum it all together. As we kind of do it this way, the thing that that always comes up, of course, especially if you're not using Python. In Python, everything is an int, there's no overflows, so you'll be fine. But if you look at another language, you can clearly see that this is actually long, so you have to be careful there. And how you would know is that n is 10 to the 5th. There are 10, the n to the 5th, n to the 5th, 10 to the 5th choose 2, roughly speaking. Maybe it's n 10 to the 5th plus 1 choose 2. But either way, like that's the order of magnitude, n square number of, like the answer can go from 0 to n square over 2, roughly, right? Sorry, excuse me, I'm having like some burps. So in that case, of course, 10 to the 5th square is going to be 10 to the 10, divided by 2 is still going to be 5 times 10 to the 9. So that is going to be long, so you have to be careful on how you do these. I don't have to, but I just want to point out at home because I am using Python, right? So yeah, so then now that we reduce this problem to a couple of different things, yeah, we can play around with how we want to do the implementation, but basically we want just the last even number, and then maybe play around with it, right? Okay, so if num sub I mod 2 is equal to 0, then last is equal to I maybe, and then now how many numbers are there? Maybe just last plus 1, I think, maybe, because if the last index is this one's at 2, that means that we can take the 2, we can add 1 and then 2, so then then on index 2 that will be 3 as the answer. So I think that's pretty much it. Okay, let's kind of run it real quick, and yeah, and I think, let me give it a submit. Hopefully this is right and I didn't make any silly mistakes. I think this is one of those things where, I mean, this is a 12-minute video, even though, I solved it relatively quickly, maybe. I don't know if you want to believe me. But my point, one last point I want to make, well, let me analyze this first. I mean, this is clearly linear time and constant space because we have like 3 variables. So hopefully that makes sense. The one thing that I want to say is that, without context, if you sometimes like look at solutions or whatever, or click on, I don't know, someone pasted the solution or something like this, you look at the code and you're like, oh, yeah, this is only, 6 lines of code. Of course, this is an easy problem. But I want to say, going with this, doing this problem in detail, hopefully this shows kind of every step of the way. And every step of the way is, I wouldn't say it's hard, but it's also not easy, right? It's kind of like, okay, I have to make this observation, I have to then transform this observation, there's like 3 or 4 steps maybe, and together, it could be very tricky, but once you really, really understand the problem, then you can kind of reduce this to like, 5 lines of code or whatever, 8 lines of code, right? So, I don't know. I think my point here is just that like the solution may look easy, and if you with enough practice, it will be easy for you, maybe, hopefully. But I don't want people to underestimate how it is based on code, and also this tells you like when you see someone's code, just because it looks clean and simple, there's a lot of thought process to make it kind of clean and simple sometimes, right? I mean, sometimes the problem is just really easy. It's kind of like I forget who this is attribute to. If you know, leave it in the comments. I think it's Mark Twain, but maybe or FDR, one of those like famous American people, maybe British. I don't know. Maybe I got it wrong, but like the famous quote is like, I'm paraphrasing it because I don't remember it, but it's like, I'm sorry that this letter is so long because I don't have time to make it shorter, right? So that's the same thing with code as well. Yeah, but also just to be also clear, sometimes for that reason, short code doesn't mean clean code. So make sure you you know optimize for clean code and not short code. Sometimes they are the same or similar or in the same direction, but anyway, um, whew, talked a lot. That's all I have for this one. Let me know what you think. Have a great weekend, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.